Hi, my name is Lexi Burfield, and this is my presentation on the Mississippi River meandering. So the purpose of my project is to determine how severe the Mississippi River meanders so local people and housing insurances knows the risk of living near the river so the insurance can be calculated accurately. Also to show certain locations of the river are more meandering than others or more dangerous in that town of living in that area. So my data, I got my data from Earth Explorer USGS. I collected Landsat, these Landsat data, collection 1, level 1 data, and searched for dates in the summer months with little to no cloud coverage in 2019, since 2020 has not had summer yet. And I was able to find several data entries where there were no clouds. I believe mine was in June. The flight path from my imagery was 2338 on the border of Mississippi and Louisiana. So my process, I first created an annotation group and drawing toolbox for the river and created a line going through the center of the river. That gave me the distance of river that I had. It gave me the distance for the expanse of river that I had. I chose not to do the entire length of the Mississippi River due to it is a very long and curving river, so that would take a long time. And I had originally planned to do multiple years, but I'd had problem making or finding out how to do calculations, so I decided to just do the year of 2019. So from that, I then created a second annotation group to get distance from one arc of a curve to another. From this data, I plugged into the sinuosity formula, determined the river is straight, winding, twisting, and meandering, which, while it is the Mississippi River, there's no spanses that are actually going to be straight because it is such a meandering river. So you can see in the upper part that is the calculation or the formula that I used. I got this from Wikipedia, and on the far left, you'll see that these are the sections that you would see to classify each one. The middle is where is how I calculated the distance for the down valley length. I had done this for several of them, and this is a image of my actual work. And on the far right is another image from Wikipedia showing how the down valley length is shown. So here are my results. As you can see, I was not able to create a full map because I do not have a mouse at the moment, so it made it very difficult to be able to try and zoom in because my zoom does not correctly work with just my computer. But as you can see, there are very small spanses where it is actually meandering, where it has the most change, and we'll see the most change. But the largest was surprising to me that it was twisting. I guess it shouldn't be as much of a surprise since it is the middle ground. It's sort of like the average area. You'll see that a lot with rivers and stuff like that. And then winding came in second. I had expected to see a lot more meandering, just because I know how much the Mississippi River has a tendency to change. But granted, I did not take into consideration that change of the Mississippi River is over hundreds and thousands of years, so it's in one particular stage of its life isn't technically as changing and evolutionary as looking over multiple hundred years. So here are my results. I calculated the actual meter length that each classification had. Excuse me. So meandering curves covered a total of 74,069.3 meters. Twisting curves covered a total of 108,334.4 meters. And winding curves covered a total of 85,499.5 meters. And in conclusion, if you look in the locations of the meandering curves on the cutting side of the river, there's a land buffer between the river and the people living nearby. This means those considered higher risk areas are relatively safe for several years due to that buffer. And though rivers do not often change drastically over a short period of time, the most amount of change is during flood, so it'd be wise for local surveyors to check the river changes after a flood. And I'm going to go back to show you where I was talking about on the meandering cutting side. So if you see in the results, on the second to bottom and bottom meandering in the red, that you can see there that there is not any like houses or buildings or anything like that in the area. And I'm sorry, I forgot to include that red shows meandering, yellow shows twisting, and green shows winding. So red is the more severe meandering, yellow is the more severe, less severe twisting, and winding is the green, less likely to make cuttings. But the cutting edge is always the one that essentially would make the point outwards because the stream is faster in that location, so it is able to cut away at the area more. But in all the cutting areas, as you can see here, and here, and here, that there are not like urbanized areas such as right here. Alright, and, oops, sorry. And here are my works cited. Alright, and thank you for your time.